So today we're talking about exponents and factoring, and on the previous page in your note packet there are all of the exponent rules and some steps for factoring. So please refer to that if you need to. Let's look at the first section here. It says simplify the following exponential expressions, and in the first one you have the same base and two different exponents. Here we are going to add those exponents, so we get x to the 10th. Here, because of the parentheses, we're going to distribute in, and now that's not the technical term for it. We're actually raising each of those things to the second power, but it kind of visually reminds you of distribution. But when you do that, you multiply those exponents, so 3 squared and x squared. Remember that there is an implied 1 as an exponent if there's not one already on it. 3 squared is 9, so we have 9x squared. Number 3, we have two bases, but this time we are dividing. So instead of adding like here, we are going to subtract the exponents and get x to the 4th. Number 4, put some of this all together. Now what I want to draw your attention to is this 2 and this 8. Don't confuse those for using exponent rules. That is just a fraction that you're going to reduce like normal. So 2 goes into 2 once, and 2 goes into 8 4 times. Okay, so now let's look at our x's. We want to subtract our x's. So we have x to the 3rd over x to the 5th, which would give us x to the negative 2, because 3 minus 5 is negative 2. And then we have y to the 7 minus 2, so y to the 5th. But now we do have a negative exponent, and we know that negative exponents need to flip. So we need to go one step further here, and we're going to have y to the 5th over 4x squared. Now if you want to put the 1 up there in the numerator, you can. 1y to the 5th over 4x squared, but it's not necessary. Okay, number 5. First I'm going to begin by putting an exponent on this 2, an exponent on this 3, and an exponent on this 1, so that everything has an exponent. And I'm going to raise everything in the first set of parentheses to this negative second power. So I get 2 to the negative 2, x to the positive 4, because a negative times a negative is a positive, and y to the negative 8 times. I'm going to distribute in or raise each thing to the power of negative 1 here. So 3 to the negative 1, x to the negative 4, y to the negative 4. Okay, there's a few ways to go about doing this problem from this point, but I'm going to first combine any like terms that I can. So here I've got 2 to the negative 2 I can't do anything with, but I do have an x to the 4th and an x to the negative 4th. I will add those exponents because there are two bases, and I get x to the 0. Then I'm going to look at y to the negative 8th and y to the negative 4th. Again, I'm going to add those exponents and get y to the negative 12th. Don't forget about this 3 to the negative 1. And now I'm going to begin flipping anything that is necessary. And I also want to look at this x to the 0. Anything to the power of 0 is just 1. So I'm going to have 1 on top. And if you visualize this all being over 1, when I flip a negative exponent, this is actually going to flip to the denominator of a fraction. So 2 squared, y to the 12th, and 3 to the 1, or just 3. We can go a little bit further. 2 squared is 4, and 4 times 3 is 12. So we have 1 over 12y to the 12th. Number 6. This one looks a little bit different, and we're not necessarily going to use exponent rules, but what we're going to use is factoring. So on the top, there's nothing I can do there, but on the bottom, something should jump out at you. We have an 8 and we have a 4, and if we want to pull out a greatest common factor, we can pull out a 4 here, but we can also pull out an x, because there are two x's here and one x here. So let's pull out an x. And remember, if you start with two terms, you end with two terms. So 8x squared divided by 4x would be 2 x, and then 4x divided by 4x is just 1, so 2x plus 1. The reason why we did that is because now you can see that the 4x's cancel, and we get 1 over 2x plus 1. Alright, number 7 is kind of working backwards here. We're going to write this out as x squared plus x plus 3, x plus 3. This does not distribute in because of the plus sign. We are going to distribute this all out or FOIL it, however you want to think about it. So we have x times x is x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9. If you recognize the special pattern there, that's perfect. But at this point we're going to combine like terms. X squared plus x squared is 2x squared, 3x plus 3x is 6x, and then plus 9. That's as far as you can go. Number 8, we are factoring completely, so we want to factor out the GCF. If I look at this, we've got 2, 8, and negative 64, so we know we can pull out a 2. And all of the terms have at least one x as well, so I'm going to pull out an x. And what we have remaining is x squared plus 4x minus 32. I'm going to bring down the 2x, and then I'm going to factor what's left in the parentheses. I want two numbers that add to before and multiply to be negative 32. So what multiplies to be 32? 1 and 32, 2 and 16, 4 and 8. The only possible answer would be 4 and 8. So we're going to have x plus 4, x plus 8 and x minus 4, because 8 plus negative 4 gives you 4, and 8 times negative 4 gives you negative 32. That is factored completely. Okay. Number 9, find the zeros or the x-intercepts of each function. Looking at graph A, you can find the zeros or the x-intercepts very easily just by looking at the picture. So you would have negative 2, 0, and 1, 0. And for B and C, you are going to factor and solve. Okay? But in order to do that, make sure that you put 0 in for y and factor and solve those. I'm going to have you try those for tomorrow. That's what you're going to be responsible for. And then number 10, what is the solution set of the equation x squared minus 9x minus 20? Again, I'm going to have you do this for tomorrow. Okay? Make sure that you get this set equal to 0 first, and then factor and solve.